Hi, everybody. So what I want to talk about with you in this video is how inequalities respond to algebra. Because what we're going to be doing is we're going to be using algebra to solve inequalities, but we need to know what happens when we do that. If I just start throwing algebra around and have an inequality here, what's going to happen to that inequality? Is there anything we have to be careful about? And what we'll see is that in general, it more or less just goes as if we had an equation. Things work pretty much the same as if we're solving an equation, but there are some little things that happen that we do have to be careful about. Okay, so let's take a look at these. Okay, so what I want to do is I want to think about this inequality here. I want to think about the inequality x is greater than 3. Okay, what would that inequality look like if we graphed it on a number line? Well, we can use this program here. It's going to sketch out a graph of what that would look like. So I'm graphing everything to the right of 3. So we'd shade everything to the right of 3 here. Now, technically, I should have an open circle around 3. Okay, so imagine there's an open circle there. And you can ignore these gaps that are appearing. That's just a glitch in the software. Okay, so that's what the inequality, just look at the top number line here. That's what the inequality x is greater than 3 would look like. Okay, what I want to do is I want to know what would happen if I applied some algebra to this. So what if I looked at the inequality x involving x plus 1? What inequality would x plus 1 satisfy? Okay, so what I'm going to do is I'm going to put x plus 1 in here, and you'll see what it's doing is that for every x here, it's adding 1 to it. That shifts it 1 unit to the right on the number line. So the old x's are up here. The new x, after we add 1 to it, is down here. So if x is greater than 3, it looks like this. It satisfies this inequality. Look at the inequality x plus 1 satisfies. It's satisfying the inequality that it's greater, x plus 1 is greater than 4. Where did 4 come from? Well, that's just 3 plus 1. So x plus 1 is greater than 3 plus 1. So what did we do to get from this inequality to this one? We just added 1 to both sides. So we can add the same amount to both sides and preserve the inequality. All right? So that's the first rule that we have. What if I subtracted something? Let's do minus 2. Put a different number here. What would happen? So now I'm looking at the inequality for x minus 2. What inequality does that satisfy? Well, think about it. What's going to happen when I trace out this inequality for x is greater than 3? We're still looking at this. What's going to happen to x minus 2? All right, well, let's look at it. Okay, there we go. We go to the right of 3, and look what we're tracing out. X minus 2 is greater than 1. Where did 1 come from? That's 3 minus 2. So look at this. I just subtracted 2 from both sides and preserved the inequality. Okay, so just like equals, you can add or subtract the same number from both sides and preserve the inequality. Okay? What happens if we multiply and divide? Let's take a quick look. Let's do 2 times x. Okay, we're going to have to slide to the right here. And let's see what happens when x, so we're looking at the inequality for 2x. And as I drag x to the right of 3, look what happens to 2x. It's to the right of 6. Where did 6 come from? It's 2 times 3. So this is greater than 2 times 3. So I can multiply both sides of the inequality by this number 2, and it preserves the inequality, right? What about division? Let's divide by 2, and what's going to happen there? Well, I'm going to drag, so here we're looking at x divided by 2. What inequality does this satisfy? Let's see. Oh, it looks like that green area down here is greater than 3 halves. How do I get 3 halves? It's 3 divided by 2. So everything seems fine, right? I can add the same thing, subtract the same thing, multiply the same thing, divide by the same thing to both sides, and everything is fine, right? Well, we have to be a little bit careful because there's something we haven't tried yet. We haven't tried multiplying by a negative number. Okay, so let me do negative 2 times x. Let's do negative 1 times x. Let's keep it super simple. That'll just make negative x. Okay, I'm going to move x back here. I'm going to zoom out a little bit. Okay, so x is greater than 3. What's that look like? That's all these x's over here. Now look what happens to negative x. It's way over here on the left. And as I increase x, negative x decreases. Right? As I move x to the right, negative x moves to the left. So things have been flipped. Things have been flipped. So if I'm going to talk about, running out of space here, I'll just go down here. If I'm going to talk about negative x, look at the inequality it's satisfying. It's less than negative 3. How do I get negative 3? Multiply 3 by negative 1. So let me rewrite this a little differently. Negative x is negative 1 times x, and that is less than negative 1 times 3. So look what happened. I started with a greater than. I end up with a less than. So this is a little different. If I multiply both sides by this negative number, I have to change the direction of the inequality. And you can see it happening here. What if I divide? What if I take x and divide by negative 2? All right. So here, I'm going to the right of negative 3 because that's my starting inequality. Look at the new inequality. Look at x over 2 here, x over negative 2. Look what's happening. If I take x and divide by negative 2, it's less than negative 3 halves. Or in other words, it's less than 3 divided by negative 2. This value right here, that green number, is exactly negative 3 halves. And as I move x to the right of 3, which is what my original inequality was telling me to do, this value goes to the left. And so it's less than negative 3 halves. And so again, I see that when I divide by a negative number, I have to change the inequality symbol to its opposite. Okay? And so that's the rule here. Okay? That's the main thing that we're illustrating. That if inequalities work exactly the same as equalities, except that if you multiply or divide both sides of an inequality by a negative number, you have to change the direction of the inequality symbol. Okay. So if I had the inequality, so if I was solving an inequality, say, negative 2x, let's do 5 minus 2x is less than or equal to 13. Okay. How would I solve this? Well, I know I can add or subtract any number from both sides, and I'm fine, right? So I can subtract 5 from both sides, no problem. But now I have to divide both sides by negative 2. So what's going to happen when I do that? Well, our rule says we have to change the direction of the inequality symbol. So if I divide both sides by negative 2, this less than or equal to becomes a greater than or equal to. Right? The negative 2's cancel here, leaves me with x. 8 divided by negative 2 is negative 4. And so there's this key step here where we have to switch the direction of the inequality symbol. Okay, so that's all I was pointing out, and I will see you in the next video. See you there.